important one is data encryption. So in a very layman term, if I explain what data encryption is about, so it is a method to convert our plain text data into an unreadable format so that only the person with the authorized access can read it and others can't, right? So moving on, I'll be giving you a brief about what we're gonna learn in this session. So by the end of this webinar, we will be covering the following concepts: what is encryption in SQL Server and various ways to do it, what is encryption hierarchy and how to encrypt as well as decrypt the database when migrated to another instance, how to recover passwords if lost while database migration, and then a Q&A session. So encryption. Encryption in SQL Server is a security feature that allows sensitive data to be protected by converting it into an unreadable format. SQL Server provides various encryption techniques to encrypt data, such as symmetric key encryption, asymmetric key encryption, and certificate-based encryption. With symmetric key encryption, the data is encrypted and decrypted using the same key, whereas with asymmetric key encryption, the data is encrypted using a public key and decrypted using a private key. Also, the third one is the transparent data encryption, which is a feature of a Microsoft SQL Server that provides encryption at the database file level. So it allows us to encrypt an entire database at rest, including the backups and log files, without having to modify the application that uses the database. So usually the choice between symmetric and asymmetric encryption depends on the specific requirements of the client. If speed and efficiency are more important, then we go by the strong security, then we go by the symmetric encryption method. And if strong security is a major priority, then we can choose asymmetric encryption. Right? So in the following session, we will be mainly focusing mainly on the data encryption using symmetric keys, right? So moving on, this is the encryption hierarchy. So this is a diagram of encryption hierarchy, but I'll be explaining you just in a while. So usually, let me first start with what encryption hierarchy is. So it actually refers to the different levels at which encryption can be implemented to protect the data. So it has the following levels from highest to lowest, like transparent data encryption, which encrypts the complete database log files, cell level encryption, which encrypts a value at a cell, column level encryption, which encrypts a column, backup encryption, which allows database backups to be encrypted, as well as the transport level encryption, which allows the data encryption as it travels over a network between a client and a server. So here in the diagram, as you can see in front of you, is like it is how the SQL Server is encrypting a data, right? So SQL Server encrypts data with a hierarchical encryption and key management infrastructure. Each layer encrypts the layer below it by using a combination of certificates, asymmetric keys, and symmetric keys. So like the first thing that you can see at the top is the DP API, which is Windows Operating System Level Data Protection API, right? So this is actually a Windows level encryption. So the SQL Server is mostly in the Windows machine, and it lives on OS, and OS governs it. So basically, DP API is the one which encrypts the service master key. Now, second one you can see is the service master key. So once the SQL Server is installed successfully, service master key is the one which is automatically created, and it takes care of encrypting the user's logins, passwords, and this key is encrypted by DP API. Now, moving on to the third one, you can see here, this is the database master key. So each database in SQL Server has its own database master key. The DMK is used to protect the symmetric keys which are used to encrypt and decrypt the data in the database. And then following that, it's the certificate. Certificates are usually the digital documents that contain a public key and information about the owner of the key. So SQL Server certificates can be used to encrypt and decrypt data, but certificates can be protected by a password or encrypted by a symmetric key. And finally, the last is the database encryption key. So since in our case, it's the symmetric key we are taking up. So this key is the actual key that encrypts the actual data, and it is present at the user database level. Okay. So now I will be moving on to give you a demo. So here are the two demonstrations that I will be showing you guys. So the demo one will be about the demonstration of encrypting a database in instance 1 and decrypting it in the instance 2 after migrating it. And the demonstration 2 will be about demonstration of a scenario where encryption key password is lost. Then how do we decrypt the data for migrating to another database in another instance, right? So I'll be taking you to my SSMS page. Yeah, so as you can see here, this is desktop honor, which is our instance 1, and this is desktop honor 2, which is our instance 2. So first of all, we'll start with the first case where we'll create a database, we will encrypt it, and then we will restore that database named as demo database in the instance 2. And in the instance 2, we will try to create this hierarchy, the encryption hierarchy again, and try to decrypt the data which we got, right? So starting off, first we will create the database here. So we have created a database table and inserted our data. We can refresh and see here. So here is our table. We can also check by querying it, how does the data looks like. So here we have one column ID, second is account number, and the encrypted text column, which is actually empty right now. So it has null values. So now we will start to create the encryption hierarchy. So it starts by creating first the master key. So we will create a master key here, encrypted by a password. Then now we are supposed to create a certification and then a symmetric key. So I'll go one by one. So now the certificate symmetric key and things are created, which means our encryption hierarchy is already set up. We can also check it here in the database. In the security column, we can see whether certificate is there and whether symmetric key is present or not. So you can see here the certificate as well as the symmetric key. So now the step 4 will be that we will be encrypting our data. So what we are doing here is that I showed you that the encrypted text column was null, right? So now we will update the account number value in an encrypted format in the null encrypted text column. Okay, so it is updating the table where the encrypted text column, we are using the encrypt by key function, using the key that we just now created, which will encrypt the account number column in a encryption format, and it will paste it in the encrypted text column. So I'll be just running this. Yeah, so here you can see the encrypted text column is actually the encrypted account numbers. Uh, we can see here. Okay. Now, if we want to see the same data in a decrypted way, so now since this data is encrypted, so now even if now you can check if you even if you now query the data, it will show as encrypted only. See, so now the data has been permanently encrypted. Now, in order, if you want to decrypt it, you need to again open the symmetric key by certificate and then select use decrypt by key function in order to see the data is decrypted. So here in the following line, we have used a cast function where we are using a decrypt by key function to decrypt the encrypted column. Our encrypted column was encrypted text. So we are decrypting this column and naming it as a name as decrypted text. So here you can see this is the decrypted text. Okay, so yeah, so we are done with the encryption process here. Now this database has been encrypted. Now, if we take a backup of this database and we restore it into the instance to the backup, the database restored there will be an encrypted one only. So now let us take a backup here first. Just, we took the backup. We will also take the backup of the certificate because we will need it later on. I'll tell you. So here, encryption by password line is there, which is the password for this backup file. Okay, so our backup has been done. Now we will go to the second instance and we'll try to restore this database. So database, let us restore the backups here. This is our instance 2. So I hope it is restored here. Let me refresh. Yeah, so we can see the demo database here. I'll also query this data to show you how this data has came here. So as you can see, the data is encrypted. Now our aim is to decrypt this data. So we already know the passwords now. So we will be first opening up the master key of decryption. This is level 1. Now the second thing is we will start to back up our certificate as well as create a new symmetric key. So the thing is that with the backup, the old symmetric key and certificate are already coming up. So we can delete it first. So then only we'll be able to restore from the old backup again. So let me just go here. First, we have to delete always the symmetric key because that's how the hierarchy allows. Now I have to move the certificate key files to the C drive first. These were files. create a certificate. It's created. Now we will create a symmetric key again. So this time we are giving another name to the symmetric key. Yeah, so now our encryption hierarchy is ready again. You can refresh and check certificate as well as the symmetric key. Now I'll be opening up the symmetric key. Yeah, so here you can see. So I tried to open the symmetric key and I decrypted the data again, and we get a decrypted value of the encrypted text. So here it is. So now we are able to, now what we have done is, let me summarize. We created a database, we encrypted it, we took a backup, we restored it in the second instance. Now in the second instance, the backup was encrypted. So we tried to replicate a new encryption hierarchy here, and we were able to decrypt the data. Now, since you've got the data decrypted, so you can put it in the table or use it whichever the way you want to, right? So this was the demonstration one. Now let me move on to the second demonstration. The second demonstration was about that here we use the password for the certificate, right? And what if we do not know the password? So what if we cannot create the certificate from the backup? So in that case, when we forget the password when we lose the password, there is another way to actually be able to restore a decrypted database in another instance. So let me go back to the first instance again. So here, now let's go back here. You can see the first instance again. So here the thing is, again, we're doing it on the same database. We have already encrypted demo database, right? So here you can see, let us see if we can still able to decrypt the demo database by the first symmetric key or not. So let me run it on demo database. So here it is. In the first instance, the decryption still works. The decrypt by key function still works because the symmetric key and certificates are already stored here and created here. So in order to use symmetric key and certificate, we do not need to put password again and again in the first on-prem instance, right? So since we do not need to put the password again and again here, what our strategy will be that we will try to create a new database in the same instance, and we will restore the database of the old encrypted DB in a new database, right? So in a new database also, the data that will come will be encrypted. So if that data will be encrypted, so our plan would be that we will again, since we will again drop the certificates, drop the keys, and create new certificate with new password, new keys, and then try to decrypt the data. All right, so let me start by creating a new database. So yeah, we have restored the old database data, which was encrypted, into our new database named as my new database. So now we will try to remove the old hierarchy present here, right? So as I told you, if we install through an old backup, the symmetric keys and certificates are automatically created. We will remove them first because here we have to create a new symmetric key and certificate in the server. So here it is, our certificates and symmetric keys are on point. Now we will be opening up the symmetric key and trying to decrypt the data. So here it is. Now in the new column, we can see that the data has been decrypted in this server, and hence we can have again the same case. We can insert this new data, insert this new decrypted data in a table, and then we can export that database wherever we want to. So yeah, that was the demonstration, guys, and thank you so much for attending. Now I'll be moving on if you have any questions further.
Hi, Anur. This is Prabhu here.
Yes, hi.
Yeah, it was very informative, Anur, and this is very new. Like without how to decrypt a data without knowing the password. But I just have one question. So, if this is the case, isn't it a security flaw in Microsoft?
I guess the case is, I guess they have developed, as per my understanding, they have developed hierarchy in such a way that you can only the person who has the on-prem access to the master database key and the service level key will be able to come to this database and create a new database, and then drop the old existing certificates and keys. So this can be the case mainly. So I don't think it is a drawback on Microsoft side, but it is maybe an alternative way that Microsoft has left to decrypt the data if in case of lost password.
Okay. So the certificate which you created, so is there any requisites like the certificate has to be on the same location with the same name, or it can also be different on it?
So certificates are required to be on the database level, and so their location has to be above the symmetric key, and the symmetric key is encrypted on the basis of the certificate. So that's how the hierarchy is maintained. Now, whether it's like in whichever server, whichever instance we go, we have to follow that pattern only. So if we deviate from that pattern, then decrypting and encrypting both the processes will be our task.
Good. So it's a new lesson learned today. Thank you so much, Anur.
Thank you so much. Thank you, everyone.
Do we have any other questions? I think we are good. Yeah.
Thank you so much, everyone. Thank you for this. Thank you for your patience. Thank you.
Yeah. Thank you, Anur. Thanks for your time. And it was indeed an informative session. So thank you all for joining the call. So we are also planning to have sessions every month, and we'll be posting the information about the session, the date and the timing ahead of time on LinkedIn. And also to the earlier registered participants, we'll send out an email. So we'll also need your support for the upcoming sessions as well. So if you have any queries, feedback, or any inputs or any specific topics which you want to be covered, kindly send your inputs to info@geopitch.com. I've just dropped the email ID in the chat box, in the meeting chat box. And we're also welcoming speakers if anybody is interested to speak on any topic as part of the webinar series. We would be very happy to host you. You can also send the details to info@geopitch.com. Thank you so much, guys. So we'll share the recording to your email IDs. We'll just host it on the GeoPitch YouTube channel, and we'll send across the link to your registered mail IDs. Thank you so much. Thank you all for your time once again. Yeah.
Thank you, everyone.
Thank you.
Thank you, everyone.
Thanks, guys. So I'll just end the call.
Thank you.